Hi everyone, my name is Leanne Phelps and I am a postdoctoral fellow with the Swiss National Science Foundation. And my current postdoc project started off focusing on reconstructing the Holocene savannas of Madagascar, but I have taken a bit of a recent detour and have been focusing on Madagascar's modern fire regimes using remotely sensed information. There is a lot of overlap in the research questions, but they focus on very different temporal and spatial scales. So I'm going to give you a little bit of an overview of the work that I've done so far, what the future plans are, and then of course how all of this relates to the upcoming workshop. All of this research pertains to vegetation change on Madagascar during the Holocene, but also in present times, and it focuses on the evolution of grassy biomes and how this relates to changes in human land use. All of it kind of orbits around this very controversial so-called Malagasy deforestation narrative, which many of you are closely familiar with, which is this idea that Madagascar used to be almost entirely forested prior to human arrival and modification. But because we don't have a good understanding of past changes in the distribution of grassy biomes, this project started off trying to clarify some of those changes. Deforestation on Madagascar today is extensive, there's no arguing that, and it's higher than a lot of other places across the tropics, but the drivers of those changes are not well understood in terms of their relative importance. Even recently, it has been shown that forest fragmentation is continuing, at least until 2014. But the estimates of forest cover and deforestation in recent times vary widely, at least in part because we don't have a good understanding of what the limits of different types of vegetation were prior to the recent past. So many of you contributing to this workshop have already done a huge amount of work that pertains to ancient and anthropogenic grassy ecosystems and trying to tease out what these relationships are. And that spans a number of different disciplines and of course underpins the whole reason for this workshop, which is to bring us all together and to kind of address all these very controversial debates head on and find places where we can agree between disciplines, but then places where we can't agree between disciplines and make sure we kind of figure out why that is and what future research needs to focus on. I think at this point most of us can agree that grassy ecosystems on Madagascar are clearly ancient to some extent, but the very contentious point is how extensive were these grassy ecosystems and how much have they been expanded by changes in human land use. So fire is a very important driver of change that gets discussed a lot with respect to the expansion of grassy biomes and impinging on forest boundaries. We looked into this in modern times, essentially saying, what is the relationship between fire, low tree cover, and high tree loss on Madagascar today? Now, of course, those relationships are going to be different in modern times than they are in the past, but these all need to be, empirically investigated. So what we did for modern times was to characterize Madagascar's fire regimes using different characteristics of burned area, and then relate this to other environmental characteristics across the tropics to make these comparisons. Here, for example, we have yearly and monthly burned area. We also have fire size, fire number, and then variability on yearly and monthly basis. We then compare these with things like NDVI, which is a measure of vegetation. So using those burned area characteristics, we define Madagascar's fire regimes. And for example, the blue areas are going to be places that have low burned area but high variability in fire from year to year. And these places are associated with forests, and these are where those like anthropogenic deforestation fires are most likely to occur. Now, we also looked at the environmental characteristics of each of these fire regimes as well as landscapes without fire. For example, vegetation density, annual precipitation, human population density, and then also resources of global interest because these were associated with the highest forest degradation anomalies on Madagascar. So we also then looked at changes in tree cover between fire regimes and no fire landscapes. The first takeaway that we have is that Madagascar's fire regimes are essentially, they're globally normal. They are similar to 88% of tropical burned area. The second takeaway is that when you look at tree loss breakdown between fire regimes and no fire landscapes, you see that tree loss among fire regimes is fairly similar to other regions across the tropics. It is still a little bit elevated, but by far the largest anomaly is happening within landscapes that do not have this kind of landscape scale fire. So in these environments, they can still have small scale fires that might be associated with things like shifting cultivation or charcoal production or other non-fire activities like commercial logging, cash crop production associated with global demand, etc. But largely, there's not landscape scale burning happening in these environments. So the main takeaway here is that these global forest degradation anomalies on Madagascar today are not a result of fire. And then more specifically, what we found is that fire is actually declining among grassy biomes, as it is across the tropics. So the globally high forest degradation that's occurring on Madagascar is further not, explained by by any kind of expansion of fire within grassy biomes and that impinging on forest boundaries. Now, this is of course going to be variable on a landscape basis, but broadly speaking, that is not supported by empirical evidence. I have some other work in progress basically doing the same things but with vegetation regimes for modern times. I won't go into that, but the other research questions that more directly pertain to the Holocene are the ones that I've started discussing earlier, which is to what degree did grassy biomes persist in Madagascar's pre-settlement history? What is this relationship with human land use? And specifically, are there similarities and differences between Madagascar and similar climates worldwide? So for example, in continental Africa, do we see similar expansions of grassy biomes that correspond to the introduction and spread of domesticates? So I've done a number of kind of different routes of research that started and kind of had to be delayed due to the COVID situation. But quickly, some of my past work reconstructing land use and land cover change has been done using published faunal and pollen records. So for example, some previous work focused on reconstructing the domestic animal niche and how this changed through time. Also looking at changes in forest and grassy biome distribution. The idea was to do something similar on Madagascar using a multi-proxy approach, and again making these kind of comparisons between similar climates. And that is in part what led to this workshop. I have done some other work on forest-savanna boundaries, trying to look at relatively recent historical changes. Unfortunately, that was halted due to COVID, but I hope to come back to that soon. And aside from that, also isotopic analysis and radiocarbon dating of domestic remains, which is in line with a lot of the work that you will see presented by other people. So, for example, Sean Hickson, he's doing the analyses on these remains that come from Henry Wright's collection at University of Michigan in Ann Arbor. Yeah, so essentially all of those different routes are all, trying to contribute to these broader questions about the distribution of Holocene grassy biomes and how these have changed in relation to human land use. But, this workshop essentially is the first step to doing that, where we need to kind of develop this cross-disciplinary understanding about data inferences and limitations between disciplines, and then also look at the most useful directions for future research and trying to clarify those, but also the future directions that are most relevant to modern problems as well. So thank you very much for listening, and I very much look forward to discussing with you in the workshop at the end of the month.